So I'm doing another favourite of mine today. This is more of an advanced variation on the blue bottle. So this is the traffic light demo, going from yellow to red and then to green. Okay, so we're starting out with our glucose. So this is going to be our reducing sugar. Same kind of situation as the blue bottle, where we're using glucose as the reducing sugar and we're using an indicator that's going to be oxidized and reduced, and we're going to do that in an alkaline condition. This recipe is straight from the RSC, the Royal Society of Chemistry. We've got some really good resources if you sign up, and you can pay for membership, or your department can pay for membership. The resources for chemistry and A-level chemistry, GCSE chemistry and A-level chemistry are really, really good. We'll notice throughout this video I'm not being super accurate with all of my rinses and transfers. There's a lot of leeway when you're making this demonstration. It is fairly forgiving, so we're going to use it for our A-level taster sessions. All of the students would have seen the blue bottle or the pink bottle previously. Nice for the prospective A-level students to be able to make something a little bit more complicated, but still really simple and really safe. So again, weighing boat, we're going 6 grams of glucose most of the time. If I was doing this for a demonstration for a teacher, I'd probably weigh it out for them, but most of the time we want the A-level students to be able to practice these skills such as weighing and decanting and tearing the balance. So that's our 6 grams. Now we're going to go with our 250 measuring cylinder, but we only want 200 ml. Again, not crazy accurate. I'm just going to undershoot that mark and then grab my squeezy bottle, and I'll just top it up to the 200 line. Just bring it up to eye level for the meniscus. Okay, so let's just finish up our glucose solution. In goes the 6 grams of glucose. In goes the 200 ml of water, and then I've got a wide neck 300 ml conical flask here, and I've got quite a big bung to fit that as well. So we're just going to dissolve that all together. I've done that because I want a bit of air in the top of the solution, and I also want a fair amount of surface area. Now, I have tried this with the ingredients from the blue bottle, which is 8 grams of potassium hydroxide and 10 grams of glucose, but it doesn't seem to work well. If anyone knows why, let me know in the comments. In this example, we're going to be using stock 1 molar sodium hydroxide. We're only using about 40 ml of that, so I would imagine it's something to do with the concentration of how alkaline it's going to be, the concentration of hydroxide ions. But if anyone knows, please let me know. Obviously, it wouldn't really have prospective A-level students weighing out sodium hydroxide either. So having 1 mole sodium hydroxide, 40 ml, it's really, really nice and easy to make up and decant for the students to use. Okay, and our dye, our indicator is indigo carmine. So this stuff is really, really fine. So actually I've decided to glove up just before. I just opened it and then realised, oh, I need to get some gloves on. So I'm going to put some gloves on. Some people would want to use this in the fume hood as well. And again, for A-level students, I would actually end up making this solution up for them just to add a few drops in rather than giving them the powder. Probably the only solution that isn't super shelf stable. I'd make this up fairly fresh. For the purpose of this instance though, I'm just going to add a tiny amount of the powdered dye into the solution. So it's 0.01 grams, I think, that's recommended on the sheet. So very similarly to blue bottle, we're looking at oxidation and reduction just by adding in oxygen to the solution. So we've got blue bottle there and we've got the pink bottle there. This is going to take a little while to dissolve. So we're just going to give that a very gentle stir, and it should go like a real nice emerald green colour. So that's getting there. That's dissolving quite nicely. If it's not quite all dissolved, you can just let it settle out and you can decant off the liquid layer and just use that. On standing, it should turn yellow and then it's ready to use. There is a bit of a trick to how to do it. You want one real gentle shake for red, and then you want to let that sit before giving one really vigorous shake for green. So it's going to take a few minutes for this solution to cycle back round from green to red back to amber, so you can do the demonstration again. The colour of this solution definitely degrades and gets kind of paler as time goes on, but you will still get around 20 cycles or about 45 minutes to an hour of playtime. But for sure, the first kind of 5 or 6 cycles are going to be the strongest, most prominent colour. Crowd reaction for this demonstration is absolutely amazing. It's really cool to see kids' kind of minds being blown when you shake it again the second time. Chemicals for it are pretty accessible. Indigo Carmine is actually a really cheap dye to buy, and the NaOH and the glucose is pretty shelf standard for most school labs. And then once that solution is spent, you should be able to put that down the foul drain with plenty of water, lots of dilutions before it goes down. You're studying up, just be aware that there are other chemistry demos that are called the traffic light demo. Make sure you're looking at the one with Indigo Carmine, sugar and NaOH. So we're going to dive into the chemistry of this, but realistically I haven't got much for you. There's lots of theories about what could actually be happening, and in true secondary school science fashion, by the end of it we're going to oversimplify it. So we're going to talk about Indigo Carmine being the molecule that is being oxidized and reduced, and the colours are down to whether it's partially or fully oxidized. But also changes in pH can give you different colours in Indigo Carmine as well. In all honesty, Deacon Fleming from the Royal Society of Chemistry has done all of the legwork for this. And there's some really interesting insights if you have subscription to the Royal Society of Chemistry or you're signed up as a member. Links to scientific papers, and there's also some really interesting information about what might be happening to the glucose molecules as well. For an A-level chemistry taster session, I think it's really interesting that the kids will turn up and make a reaction that isn't completely or fully understood yet, and that science is about building on previous work and other people's experiments. Now, I'll link the RSC video in the bottom in the description for you to have a look at. And that'll have a link to their website where you can become a member. It's totally worth it for any chemistry technician or chemistry teacher. Their resources are really amazing, and I've actually been given loads of opportunities through the RSC, so big ups to them. So that is everything we do for these reversible redox reactions. That's the blue bottle, the pink bottle variation using Resazurin, and then the traffic lights demonstration using Indigo Carmine. Give these a try, let me know how you get on, and I'll see you in the next one. Laters.